There are times when you want to be able to sterilize without getting your substance or your object wet. Powders come to mind, metals that will rust. In these cases, we use gaseous agents, by which we mean ethylene oxide, propylene oxide, and beta-propiolactone. And these are the structural formulas. So we can use these gases to sterilize either large things or, as I mentioned, temperature-sensitive items, moisture-sensitive items, items that are too big to use ionizing or non-ionizing radiation on. And these are very effective. Their mode of action is similar to glutaraldehydes. They cross-link proteins and other molecules, and if you can't move, if you're cross-linked, then a structural protein or an enzyme isn't going to be effective, and it kills the microbe. Now, lots of places use, especially ethylene oxide. It penetrates through paper, penetrates through fabric wraps, gets into every crack. It's very effective, and it is a sterilization agent. But you have to be careful. It's explosive. So we mix it with other gases so that the hospital or the dental office or NASA is less likely to explode. So this is not something that you're going to use at your home. Also, it's poisonous. If it'll cross-link the proteins and other biological molecules of microbes, it's going to cross-link yours. So folks who are using these gaseous agents in sterilization procedures have to be very careful. They're well trained. The other thing is it's carcinogenic. So you want to limit your exposure. Also, say we're using these products on, say, a artificial hip to be implanted, artificial heart valves, that kind of thing. You don't want residual of these gaseous agents to be into the patient. So what we do is we degas all of these, all of the things that we've sterilized with these gaseous agents for at least 48 hours. And then in manufacturing, they will take a bit from each lot, send it to companies who test for residual gaseous agents to make sure that they've completely degassed so that everybody's safe. On to enzymes and antimicrobials. These are products that are normally made by bacteria and other microbes in their continual warfare against other microbes. I use the example often of soil, but this happens in water communities and also, say, in your gut. So what we're doing is we're taking natural methods and using them to our own use. So let's talk about enzymes first. There are specific enzymes that other microbes produce that kill other microbes. And the most commonly used one in industry is lysozyme. Lysozyme punches holes in peptidoglycan. So it's especially effective against gram-positive bacteria. Less so on gram-negatives, but it's still somewhat effective. And so what we do is we take lysozyme and we add it to, say, milk. And then your cheese doesn't have, say, Staphylococcus aureus. Staph aureus food poisoning causes projectile vomiting. It's also known as the 24-hour flu, so you really don't want that gram-positive organism growing in your food. So we add lysozyme and it keeps the numbers down. Now, before you freak out that there's enzymes in your food, you also produce lysozyme. Lysozyme is produced by humans in our tear glands. So as your tears are keeping your eyeball moist, lysozyme is keeping the numbers of your normal skin bacteria that you don't want in your eyes, keeping those down. So don't freak out about eating lysozyme. Prionizyme is another one, and what we're doing is it's a new enzyme that we're developing for cleaning instruments of prions. So prionizyme will go in and snip prions because there's not much else we can do to inactivate prions. Currently, if you do any kind of brain or nervous tissue surgery, say on the spinal cord. All of those instruments are completely incinerated when you're done. Once we develop prion-enzyme, we can clean those instruments of prions, and we don't have to worry about passing on prions from patient to patient to patient. It's actually quite exciting. Other antimicrobials, including antibiotics, which we will be talking about in more detail in the next chapter, are used outside of the body to control microbial growth. And two examples that the book brings up is niacin, which controls bacterial growth, and it's often added to food in the food industry, and natamycin, which controls fungi, also in the food industry. Let's talk about development of resistance to microbial control methods. It's one of those things that's going to happen. But let's talk about the swing of the pendulum. In other words, back before we had the germ theory of disease, in other words, bacteria, fungi, protozoa, viruses, etc., caused disease, we didn't know that this sort of thing caused disease. In fact, we thought that bad smells caused disease. Now, before you laugh at your ancestors, you can't see microbes. If you can't see them, you don't know that they're there. But if something stinks, that indicates that there's been microbial growth oftentimes, and it tells you that you shouldn't eat something. So it's understandable that you would carry that over to, your downwind from a tanning factory. That stench is going to make you physically ill. People weren't all that concerned about maintaining their personal cleanliness, and if it didn't stink, it was okay. Well, once we discovered that microbes, even when they're in low numbers, to the point where they're not causing a stench, cause disease, we became exceptionally clean. And now the question is, have we gone too far? Have we gone from being totally unconcerned about the hygiene of ourselves and our surfaces to the point where we're overly concerned about it and we're now causing ourselves harm in a different way? Let's talk about antimicrobials in soaps specifically. Personally, I have a hard time finding hand soaps that do not contain antimicrobials, usually triclosan, which, if you remember, is a phenolic. There have been studies, and there is no clear benefit in using antimicrobials in your hand soaps, your dish soaps, and so on. Most of these surfactants, or surface active agents, are physically removing the microbes. So do you really need to kill them as well as physically remove them? Well, because of our current society, the gut instinct is to say, yes, are you crazy or what? But there's really no clear benefit. And there have been studies that have linked use of these types of antimicrobials in the development of resistance to other control methods, especially antibiotics. There have been other studies that have refuted this, but when there's no clear benefit and there's the possibility of developing resistance, should we be using them? And then there's the innocent bystanders. If we're using an awful lot of antimicrobials, we're inhibiting the transfer of our normal microbiota to other people. Well, you're saying, isn't that a good thing? Well, there is a new trend in microbiology in talking about our normal microbiota and low-level pathogens as old friends, because studies have been found that if you have some of these low-level pathogens in your system, your normal microbiota in your system, it downregulates your immune system so that you don't develop allergies and autoimmune diseases. So the question is, have we become too clean? And when I say have we become too clean, I'm talking about in our homes and in our offices and schools and other public areas. There's a whole nother discussion when we talk about clinical environments, because you have large numbers of people coming in who are sick, and they probably have high levels of non-low-level pathogens. So don't think clinical environments in this discussion, think home and other areas. So to the question of have we become too clean in our homes and other areas, non-clinical areas, I would say yes. On the other hand, there are other people who may disagree with me, but even if we come to the decision that we are being too clean, we don't want to go back to the bad old days when 1 out of every 4 children was dying of a bacterial diarrheal disease. So there's got to be a happy medium. Well, that's it for this topic. Here is a table that covers all of the chemical control methods that we've talked about. Goes over the mode of action, level activity, and some of the uses. This is a very good table to, say memorize, hint, hint, hint. And here are reminders of what the learning objectives for this topic are.